We had a very interesting discussion with the team this morning, and since this is a broad subject and touches many different features, we are going to discuss now what we discussed with the team this morning.
Theo, you chose an interesting topic, elasticity. Everyone talks about elasticity nowadays, but there is a lot of confusion in the market. Can you please a little bit explain what elasticity is compared with scalability, for example?
Yes, Alex. So we hear often that the promise of cloud is to use exactly what you need and pay for exactly what you use when you use it, right? Imagine trying to do it when you are in your own data center. It would not be very easy, if possible at all. Here comes the elasticity that we can get from the cloud infrastructure as a godsend solution. With elasticity built in, customers can avoid expensive over-provisioning for just-in-case scenarios and instead deploy additional resources only when they are needed and pay just for as long as they use them. So, scalability generally refers to more predictable infrastructure expansions that are addressed in a more static way, whereas elasticity is the ability to grow or shrink infrastructure resources dynamically as needed to adapt to sudden workload changes.
Okay, Theo, so elasticity sounds very flexible. So in terms of compute shapes, what do we offer? Anything that described as elasticity according to your definition?
Yes, Belit. I'm very excited to show you how easy it is to deploy a flexible shape and choose the number of OCPUs and the amount of RAM that you need. In OCI, we offer the E3 flexible compute shape, which is a shape based on the AMD ROM processor with a customizable number of OCPUs. When you create a VM instance using the flexible shape, you select the number of CPUs that you need for the workloads that you will run on this instance. Let me show you that. If we go to our compute instance and choose the AMD ROM processor, we can see that you can choose and you can customize the number of OCPUs and the amount of memory allocated to a flexible shape. And you can choose independently the number of OCPUs. We can see here. The only thing is that per OCPU, you need to choose between 1 and 64 gigabyte of memory. So this is an independent dial here. And this is really exciting, yeah? So up to now, customers needed to choose a very specific shape. And if they needed a little bit more memory, they needed to go to upgrade to the next bigger shape and maybe pay unnecessarily bigger costs on that. This now gives you a very, very good level of elasticity. This is the definition of elasticity according to my
This is good. This is great.
And when it comes to cost, because I see that we are supporting both Intel and AMD, is there a price difference between those two?
Yes, since you pay exactly for the number of OCPUs and the amount of memory, and this is different than paying in Intel. We don't have that flexibility. So in Intel, you pay for the shape that you choose. So it depends really. If you have a bigger shape here, if you end up with a bigger shape, it could be a little bit more expensive, but still AMD is a little better in terms of cost.
Okay, what is the maximum memory available for one CPU?
For one CPU, you can get up to 64 gigabytes. But in total, for example, if you see here, if I choose the number 1 of OCPUs, you can get up to 64. The maximum number of OCPUs is 64, in which case you can choose a total amount of memory of 1024 gigabytes.
Great features, Theo. But you mentioned that, what do you mean by changing a shape? For example, usually we are running some existing applications in a shape. What about this application when you change the settings or the shape?
That's a good question, George. I'm tempted to use this metaphor that I hear somewhere and I heard somewhere and I liked it a lot. It's like changing the tires of your car while you drive on the highway, or rather the car itself altogether, I might say. So you can change the shape of a virtual machine instance without having to rebuild your instance or redeploy your applications. It's very important. This lets you scale up your compute resources for increased performance or scale down to reduce costs. When you change the shape of an instance, it affects the number of OCPUs, the amount of memory, the network bandwidth, and maximum number of VNICs for that instance. Optionally, you can select a shape that uses a different processor. The instance public and private IP addresses, volume attachments, and VNIC attachments remain the same. Let me show you that. For example, let's get to that instance, yeah? And for some reason, we need to go to a different instance to test something or to accommodate a different need. If we choose Edit Shape, we can see that we can choose from this family of processors, the AMD-ROM, or even from the Intel shapes, the Intel-based shapes, or we can have a special need, or we need to go to a legacy or another kind of processor. In that respect, we choose what we need to upgrade to, and then we can proceed. And then the shape will have a small amount of downtime in order to reboot, and it will start again in the new shape. This is a fantastic feature. So you see that you can choose from a range of supported shapes, including legacy ones. And this is also very, very important for some customers.
And how this will affect my running services?
As I said, when you change your shape, it will require a small amount of downtime in order to reboot the shape. Other than that, everything remains the same, and you don't need neither to rebuild your applications nor to change any existing setting.
Oh, okay. I guess this is amazing, Theo. This kind of flexibility can save lots of hours for administrators. I mean, yeah, it can save a lot of time. Are there any other components that I can incorporate in terms of flexibility?
Fatih, some people at Oracle made this question that you just asked and processed that, and they came with some new ideas as well. So just recently, we introduced the dynamic shapes for the load balancing service on OCI. Now you can update the bandwidth shape of your load balancer within minutes while preserving your backend applications and load balancer instance properties. Isn't that good? Let me show you. So if you go to the load balancers, so you specify the shape that determines the load balancer's total provisioned maximum bandwidth at the beginning in ingress and egress traffic, right? Until now, you had to choose a shape with enough room to support your anticipated future performance needs. In that case, for example, when we created this load balancer, it was in 100 megabits. So if your bandwidth needs changed, you had to launch a new instance and migrate all your applications to the new instance. With the new dynamic load balancer shape feature, you can now update the bandwidth shape of your existing load balancer without changing any other of the load balancing or backend server properties. Just go to update shape, and you can choose your new needs as regards the bandwidth from this menu. That's a really good feature. You just click Save Changes, and then the load balancer will be updated. It's according to the previous description of updating shapes in compute under the same logic. This is true elasticity. You don't need to reconfigure or reinstall any applications to take advantage of the new shape.
So it's updated. Great.
Yeah.
But what happens in a bigger picture when you want to accommodate, for example, spikes, where you have a limited time of increasing workloads? What can you leverage then?
Nice question, Alex. We provide a solution not only for unpredictable, but also for anticipated demand, which requires scaling our resources. So up to now, we could implement autoscaling by watching. We can refer to what you say by implementing what we call autoscaling. Up to now, we could implement autoscaling by watching metrics like CPU or memory, which we could configure certain thresholds. So when they were reached, the addition or removal of resources was initiated. Let me show you that. Up to now, for example, we had the metric-based autoscaling. As I said before, you could go to the performance metric. Now, many customers found that challenging to control the compute resources consumption and the cost optimization and the maintenance of adequate provision capacity for anticipated traffic demand. This was for cases that the traffic demand was dynamic, but in cases of anticipated traffic demand, autoscaling introduced some new ways to affordably scale the predictable load patterns. In that case, we have this schedule-based autoscaling. This is a new feature. So you can come here to the schedule-based autoscaling and choose from a variety of schedule-based pre-made templates, or you can make your own custom autoscaling schedule. So now you can create up to 50 schedule policies, including one-time scaling, and scale out once at a specific date and time, or recurring scaling at regular dates and times. This thing scales out to 500 instances per instance pool. You can turn it off or on. It's a feature that you can disable or enable. And you have integration with serverless automation. It's important. It means that you can get cloud native integration to create event rules on scaling actions or when a pull update is triggered to automatically respond and execute actions such as notifications, functions, streaming, messages, etc. So now you have that as well, and this is one more weapon in your elasticity arsenal.
So I can scale down for the weekend, right?
Yeah, we can do lots of things like that.
Or should I use it to scale up basically my e-commerce on Black Friday?
That's exactly the case that it was in the mind of the developers of that feature, I guess.
During Christmas?
Scale up on demand, basically. It's good for certain purpose. There's a report comes in end of the month. You need more power. You just scale it up by setting up this.
Yeah, when you anticipate that, as you said, for example, in the Black Friday occasion, you can do it beforehand. So you don't need to go through the part that you will wait for your CPU utilization to raise, and then it takes some time. So here you can do it beforehand, so you are ready in the anticipating your raise of the workload.
Can you select one of those quick start things? Sorry, George. I wonder if it is in the cron top notation.
You mean here? You just come here.
Yeah.
But if you go here, for example, you see how it looks like. It's really simple. I mean, it's made. If you want to create another policy, you come here and you just add. So you can have, as we said, many policies, up to 50 scheduled policies.
It's an interface to write a cron task.
Yeah,
It looks that way.
So as you say, cron values here. It's cron expressions.
It's cron tabs.
It's real good.
Yeah, and also, Theo, I would like to add that some customers will really appreciate this feature that wants these financial statements every end of the month. So they need more power for their reports. So they will really like this.
Yeah, exactly. You can get that in your reports and you can see the impact. Financial people will really appreciate that.
I love this feature, Theo. So what about billing part? Does autoscale reflect to billing too? Because more power means more cost and less power means less cost.
Flexibility on billing is very important. It's a very good and very nice question, Bilek. So compute instances now are built per second of usage rather than per hour. This helps you reduce costs when using instances for short amounts of time. And so for VMs, you have a minimum charge of 1 minute. For bare metal instances, you have a minimum charge of 1 hour. After the first minute for VMs and the first hour for bare metal instances, the usage is built in 1 second increments. This is a very important feature as well. And it reflects on this elasticity capability, as you said. So whenever you change using all the previous features that we demonstrated, your billing will also follow on that.
Yes, it sounds fair, Theo, and I think many customers will appreciate this per second billing. Previously, you mentioned something about automatic CPU scaling in the autonomous database. Are you going to tell us anything about this also?
Yeah, sure, George. Let me navigate in the autonomous database to show you what we mean. This is a very, very powerful feature as well for autonomous database. For both services in the autonomous data warehouse and the autonomous transaction processing, this works. So let me show you that. So let's go to this database. So you can select the auto scaling to allow the system to automatically use up to 3 times more CPU and I/O resources to meet your workload demand compared to the database operating with auto scaling disabled. Yeah. So when you create a database, this is by default enabled. The additional resources are available until you disable auto scaling. So you go there and you deselect it. So with auto scaling enabled, the database can use up to 3 times more CPU and I/O resources with you not having to worry about anything. You just check that, you click it there. You don't have to worry about anything. When the demand comes, it does it automatically. Let me show you. So if you click auto scaling here, that's all you have to do. Just click auto scaling, and if your initial database is configured to use 1.0 CPU, it scales up to 3 times that. And you also have as regards some separate feature, when you start your autonomous database, you can choose, of course, your storage and your CPU count. You can change that anytime. So another thing is that you have also storage scaling, as you can see here. Yeah, autonomous databases allows you to scale the storage capacity of the database at any time without impacting the availability or the performance. This is true elasticity, isn't it?
Indeed, it's really true elasticity, I will call it. And do you have any other storage options? So far, we have been talking about all the compute instances up now. We didn't mention anything about storage. It looks like we are ready for the spiky or bursty workloads. What about the storage? Storage performance, sizing?
Fatih, this is my favorite area. So you are covered in that as well. So the elastic performance feature of the Oracle Cloud Infrastructure for block volume service allows you to dynamically change the volume performance. And then it enables you to pay for the performance characteristics that you require independently from the size of your block volumes and boot volumes. Yeah, this is really good. This is amazing. This feature includes the concept of volume performance units. We call them VPUs. You can purchase more VPUs to allocate more resources to a volume, increasing the IOPS per gigabyte and throughput per gigabyte. And you can also have the flexibility to purchase fewer VPUs, and that reduces the performance characteristics for a volume. But however, it also provides cost savings, right? So you can choose not to purchase any VPUs at all, which can provide significant cost savings for volumes that you don't require to have increased performance. Just let me show you that. It's one of the features that are really unique and amazing. So you go here, the block volumes, and depending on what you need to use, for example, you create a new block. Let's go to this one. We see that we have a new block volume, and by default, when you create it, it is in balanced. It is in balanced mode. You can edit that at any time, and this is as well when you create the block volume. So you say in balanced, you have 25,000 IOPS, which is like 60 IOPS per gigabyte, and your throughput is 480 megabits per second. So at any time, if you want to tune it to something with higher performance, you can do that from here. You can change also the volume size, and the other amazing stuff, you can go to lower cost, for example, which means that you go to 2 IOPS per gigabyte, and your throughput also gets to 245.76 megabits per second. And You see that you can just move this dial. And also you have what we have as what we call auto-tune performance. With auto-tune performance, you change the volume performance to lower cost automatically when the volume is detached. So you can also save money when your volume is not used, you detach it, and you can have significant cost savings to that as well. Isn't that true elasticity?
I think this one is unique.
Yeah, this is unique, and it's really amazing. Many customers are really appreciating that. Thank you guys for being today here in this interesting conversation about elasticity. It was really amazing, and I'm sure that anyone that watched that video will go straight away to the console and try out those features.
Thank you, Theo. Amazing stuff.
Yes, thank you, Theo.
No, thank you.
Thanks,
I really
guys.
liked the demos. Thank you.
Thank you, Theo, so
Your
much.
day.
Thank you. Bye-bye.
Have a great day. Bye.